Imagine looking up at the night sky and suddenly witnessing a star that wasn't there before, bursting into brightness like a cosmic firework. This isn't the plot of a science fiction novel, it's the real-life story of T Corona Borealis, a star in the constellation known as the Northern Crown. Located in the northern hemisphere, the constellation Corona Borealis, which translates from Latin to Northern Crown, holds a fascinating secret. One of its stars, T Corona Borealis, has a fiery personality. A T Corona Borealis, often abbreviated as TCRB, is a special kind of star, a variable star. Unlike most stars that maintain a consistent brightness, TCRB has a tendency to vary dramatically, sometimes explosively in its luminosity. Known as the third discovered variable star in the constellation, TCRB has intrigued astronomers for centuries. Why? Because every 80 years or so it surprises the universe with a stunning outburst of brightness. When this happens, it appears as if a new star has suddenly appeared in the sky, a phenomenon called a nova. But what's really happening with T Corona Borealis? Let's dive into the science. TCRB is actually a binary star system composed of a red giant and a white dwarf. The red giant is a bloated, expanding star, while the white dwarf is a dense, dead star, no longer undergoing fusion, but still glowing with the residual heat of its former life. As the red giant expands, it reaches a point where its outer layers of gas are no longer gravitationally bound to it. This gas begins to spill over into the white dwarf's gravitational domain, known as the Rush lobe, and slowly accumulates on its surface. This process of gas transfer is gentle, but it builds up. Over time, the pressure and temperature on the surface of the white dwarf increase to a critical point. And then, in an instant, the hydrogen gas ignites, triggering a thermonuclear explosion. This is the nova we see, a spectacular release of energy that propels the accumulated gas out into space. What's fascinating is that T Corona Borealis doesn't just do this once, it repeats this explosive dance approximately every 80 years. Each explosion ejects a shell of gas, which slowly moves away from the star over time. Telescopic images have revealed these layers of gas, providing a historical record of all the previous times TCRB has gone nova. It's like reading the star's diary, a celestial history of explosive outbursts. But why are scientists so interested in T Corona Borealis now? Because the last time it erupted, the world didn't have the advanced technology we do today. We didn't have powerful space telescopes or sophisticated observatories to study it in detail. This time, however, we're ready. With our arsenal of modern telescopes, both on Earth and in space, astronomers are prepared to capture every moment of this stellar explosion, making T Corona Borealis the best-studied nova in history. It's important to note that novae, like those produced by T Corona Borealis, are not the same as supernovae. While both involve explosive events in binary star systems, a supernova is far more dramatic. A supernova occurs when a white dwarf reaches a critical mass limit, about 1.4 times the mass of our Sun, leading to a catastrophic collapse and explosion that can outshine an entire galaxy. In contrast, a nova is a relatively gentler explosion. It's still powerful, but it's more like a stellar burp compared to the supernova's cosmic roar. So the next time you look up at the night sky, think of T Corona Borealis, a star with a fiery past and a spectacular future. Its explosions are a reminder of the dynamic and ever-changing universe we live in, and how even the stars themselves have stories to tell. And perhaps, just perhaps, we might witness this cosmic dance again in our lifetimes. Keep watching the skies.